Good morning, students. Today we continue our lecture on gas laws. This lecture is presented by me, Panit Ghatak, your chemistry teacher. So, let's begin. So, today's topic is gas equation. Okay. In the last few classes, we have already seen Boyle's law, Charles' law, as well as the absolute temperature or absolute scale, okay, or absolute zero. Okay, so we have already seen all of this. Okay, in today's class we're gonna discuss about gas equation. Okay, so let's begin. So here, by this time you have already know that Boyle's law, the mathematical expression of Boyle's law is P1 V1 is equal to P2 V2, as well as the Charles law expression, that is where Charles law is being stating that if the pressure is constant, then the volume is proportional to temperature, that is V is proportional to temperature. Okay, but whereas Boyle's law states that if temperature is constant, then volume is inversely proportional to pressure. Okay, so from that note we have getting two equations, that is for Boyle's law we are getting P1 V1 is equal to P2 V2, and for Charles law P1 by T1 is equal to V2 by T2, or we can easily write this as a V1 by V2 is equal to T1 by T2. Okay, T1 by T2. So okay, so we can write this Charles law as this format as well. Okay, so Boyle's law and Charles law we have already studied. Okay, Boyle's law means stating that at constant temperature the volume of a particular gas is inversely proportional to the pressure, and Charles law stating that if pressure is constant, then volume is proportional to the temperature, that is the absolute temperature in the absolute scale, that is the absolute temperature of that gas. Okay, so these two have been, we have already discussed this Boyle's law and Charles law, so that we have already know the mathematical expression of Boyle's law and Charles law. And there is a next law, there is a third law that is called as Gilsher's law. Okay, Gilsher's law is being stating that if pressure and temperature is almost same, or we can say at NTP or at STP, that is normal temperature and pressure and standard temperature and pressure, if NTP or at STP, for any gases the volume is almost same. Okay, so we can easily say like that as well. Okay, although there is a bigger explanation as well, but when you will understand this Gilsher's law when in the next class, in class 10 we will get to understand the Gilsher's law, but till now it is no need to understand that because this is not in your syllabus. Okay, just know that for Gilsher's law we have a mathematical expression of P1 by T1 is equal to P2 by T2. Okay, so right now we're gonna merge these three equations and to form a new equation. Although we can easily do that without combining these three gas equation, that is Boyle's law, Charles law and Gilsher's law, but the combined gas law equation is what we called when we have combined these three equations, that is Boyle's law, Charles law and Gilsher's law. That is here in this slide you can already find that the combined gas law has no official founder. It is the combination of Boyle's law, Charles law as well as Gilsher's law. The combined gas law is the following equation, that is the P1 V1 by T1 is equal to P2 V2 by T2. Okay, so combined gas law equation is having no official founder, but it is derived from three equations, that is Boyle's law, Charles law and Gilsher's law. And the combined gas law equation is P1 V1 by T1 is equal to P2 V2 by T2. Okay, and remember one thing, this equation is being derived from all these three equations, that is P1 by V1, here V1 is there and P1 is there, so P1 by V1 by T1. and this is also according to this Boyle's law as well. P1 V1 by T1, P1 V1 equal to P2 V2 by T1 is being coming from the Charles law. Okay, so P1 V1 by T1 is equal to P2 V2 by T2. Okay, so here it is also being used as well. Okay, so this equation is being, this combined gas law equation is being derived from these three equations, that is Boyle's law, Charles law, and Gilsher's law. Okay, you will understand the Gilsher's law in the next class as well. Okay, so this combined gas law equation is highly important for you in the respect of numericals. Okay, okay, here is there is six terms, that is P1 P2 V1 V2 and P1 T2. If there is, we know five terms, if we know five terms of this equation, then we can easily find out the sixth term. Okay, the sixth term in this equation. Okay, so this equation, this gas equation, combined gas law equation is highly important for the numerical purpose. Okay, and you have to remember from where it has been derived. Okay, from which equations it has been derived. Okay, so you have to remember all that. Okay, and especially you have to remember this equation as well, that is P1 V1 by T1 is equal to P2 V2 by T2. Okay, so in this today's lecture we have discussed the gas equation and from where it is derived. Okay, I hope you have understood this part very well. If you have any kind of doubt, you can always ask me by the comment section below. Okay, so thank you very much.